According to the National Electrical Code, specifically Section 210.11, C1, all bathroom branch circuits must be dedicated to the bathroom. This means you cannot supply power to lights and other equipment in the bathroom from the same circuit that serves other areas outside the bathroom. However, there is an exception for existing lighting circuits. Bathrooms with existing lighting circuits that are not in violation of any applicable codes can continue to use these circuits for lighting fixtures. If you are adding a new receptacle to the bathroom, you must install a new dedicated circuit for that receptacle. The new circuit for the receptacle must be a 20 amp circuit protected by a ground fault circuit interrupter, GFCI. The existing lighting circuit should be checked to ensure it is properly wired and not overloaded. If the existing lighting circuit is found to be overloaded or improperly wired, it should be corrected before you connect any new fixtures to it. In summary, firstly, ensure compliance with NEC Section 210.11. C1 regarding dedicated bathroom circuits. Secondly, understand the exception for existing lighting circuits that meet code requirements. Thirdly, install a new dedicated 20 amp GFCI protected circuit for any new receptacles. Fourthly, inspect and correct any issues with the existing lighting circuit before adding new fixtures. Let's delve a little deeper into each of these points. Firstly, Section 210.11. C1 of the NEC is very specific about the need for dedicated circuits in bathrooms. This requirement is primarily for safety. Bathrooms are considered wet locations, and electrical hazards are more prevalent in these areas. By having a dedicated circuit, the risk of overloading the circuit and potentially causing a fire is reduced. Also, it ensures that if a fault occurs in the bathroom, it does not affect other critical circuits in the house. Secondly, the exception for existing lighting circuits is a practical consideration. Many older homes have lighting circuits that also serve other areas. Rather than requiring a complete rewiring of the entire house, the code allows these existing circuits to remain in use as long as they are not in violation of any other applicable codes. This means the circuit must be properly grounded, have adequate ampacity for the load, and be in good working condition. Thirdly, when adding a new receptacle in a bathroom, a new dedicated 20 amp GFCI protected circuit is mandatory. This is another crucial safety measure. GFCI protection is required for all receptacles in bathrooms to prevent electrical shock. A GFCI monitors the current flowing to and from an appliance. If it detects an imbalance which could indicate a leakage of current to ground, it quickly interrupts the circuit, preventing a potentially fatal shock. The 20 amp rating ensures that the circuit can handle the typical load of bathroom appliances such as hair dryers and curling irons. Fourthly, it is essential to inspect and correct any issues with the existing lighting circuit before adding new fixtures. Over time, wiring can deteriorate, connections can loosen, and insulation can become damaged. An overloaded circuit can overheat, leading to a fire hazard. Therefore, a thorough inspection is necessary to identify and address any potential problems before adding any new load to the circuit. When performing any electrical work, it is crucial to follow all applicable codes and safety precautions. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Remember that electricity can be dangerous, and improper wiring can lead to serious injury or death. In addition to the NEC requirements, local codes may have additional restrictions or requirements. It is always a good idea to check with your local building department to ensure compliance with all applicable regulations. Also, consider the long-term needs of the bathroom. If you are planning to add more electrical devices in the future, it may be wise to install a larger circuit or additional circuits to accommodate the increased load. This will prevent the need for future rewiring and ensure that the electrical system can safely handle the demands placed upon it. When selecting electrical fixtures and appliances for the bathroom, choose products that are specifically designed for use in wet locations. These products are typically sealed to prevent moisture from entering and causing damage or electrical shock. Also, make sure that all electrical products are properly grounded. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. In summary, bathroom electrical wiring requires careful planning and attention to detail. By following the NEC and local codes, and by taking appropriate safety precautions, you can ensure that your bathroom is safe and functional for years to come. Remember to prioritize safety, and when in doubt, consult with a qualified electrician. The key takeaways are the dedicated circuit requirement, the exception for existing lighting, the mandatory GFCI protection for new receptacles, and the importance of inspecting existing wiring. By adhering to these principles, you can create a safe and efficient electrical system for your bathroom. Always remember to turn off the power at the breaker before working on any electrical circuits. Use a voltage tester to verify that the circuit is energized before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves. And never work on electrical circuits in wet conditions. These precautions can help prevent electrical shock and other injuries. The NEC is updated every 3 years, so it is important to stay current with the latest edition. The NEC is a comprehensive document that covers a wide range of electrical topics. It is intended to provide guidance for safe electrical installations. However, it is not a substitute for professional training and experience. If you are not a qualified electrician, it is best to leave electrical work to the professionals. Also, keep in mind that the NEC is a minimum standard. You may choose to exceed the requirements of the NEC in order to provide an extra margin of safety or to improve the performance of your electrical system. For example, you may choose to install arc fault circuit interrupters of size in addition to GFCIs. ASIs provide protection against arc faults, which can be a common cause of electrical fires. Electrical safety is not just a matter of compliance with codes and regulations. It is also a matter of common sense and good judgment. Always be aware of the potential hazards of electricity and take steps to protect yourself and others from harm. Regular inspections of your electrical system can help identify potential problems before they become serious. Look for things like frayed wires, loose connections, and damaged outlets. If you find any problems, have them repaired immediately by a qualified electrician. And finally, remember that electricity is a powerful force. It can be a valuable tool, but it can also be dangerous. By following the principles of electrical safety, you can harness the power of electricity safely and effectively. When working with electrical circuits, it is also important to understand the different types of wiring. The most common types of wiring used in residential electrical systems are non-metallic sheath cable, NM cable, also known as Romex, and armored cable, AC cable, also known as BX. NM cable consists of 2 or more insulated conductors enclosed in a non-metallic sheath. It is typically used for general-purpose wiring in dry locations. AC cable consists of 2 or more insulated conductors enclosed in a flexible metal sheath. It is typically used for wiring in exposed locations or where mechanical protection is required. When installing wiring, it is important to follow the manufacturer's instructions and to use the proper tools and techniques. Wires must be properly supported and secure to prevent them from becoming damaged. Connections must be made tightly and securely to prevent overheating. And all wiring must be properly grounded to provide a path for fault current to flow back to the source. Also, when working with electrical circuits, it is important to understand the different types of circuit breakers. The most common types of circuit breakers used in residential or electrical systems are standard circuit breakers and ground fault circuit interrupter. GFCI circuit breakers and arc fault circuit interrupter are ASI circuit breakers. Standard circuit breakers are designed to protect against overloads and short circuits. GFCI circuit breakers are designed to protect against ground faults. ASI circuit breakers are designed to protect against arc faults. When selecting a circuit breaker, it is important to choose one that is properly sized for the circuit it is protecting. The circuit breaker must be able to handle the maximum load that the circuit is likely to carry. If the circuit breaker is too small, it will trip frequently. If the circuit breaker is too large, it will not provide adequate protection against overloads and short circuits. In addition to circuit breakers, fuses are also used to protect electrical circuits. Fuses are similar to circuit breakers, but they are not resettable. When a fuse blows, it must be replaced. Fuses are typically used in older electrical systems. When replacing a fuse, it is important to use one that is the same size and type as the original fuse. Using a fuse that is too large can damage the electrical system. Furthermore, electrical work should always be performed with the power turned off at the breaker. Double check with a non-contact voltage tester to ensure the wires you are working with are indeed dead. If you are unsure, consult a qualified professional for assistance.